Alright guys, welcome back. We have another question from the first chapter of the fundamentals of electric circuits. And in this one, on the figure that we see on the right hand side, we can see the power consumption of a certain household in one day, starting from 12 to 12. And we need to calculate the total energy consumed in kilowatt hour and the average power per hour over the total of 24 hours. So we know power is the rate of consuming energy or using energy over time. So for finding the total energy consumed, we basically need to, so here we can see that energy is equal to power times time. So the total energy that's consumed would be sum of all powers times time during these 24 hours that we have. So can start that. So going from 12 to 6, we have a 6 hours interval where we have 200 watt power. So 200 times 6 hours plus we're gonna have 2 hours of 800 watt plus going from 8 to 6, that's going to be another 10 hours of 200 watts, and we're going to have again 6 to 10, another 4 hours of 1200, and the last one again 2 hours of 200 plus, and that's going to give us the total amount of the power. So we just have to calculate this. So first one, we can actually factor 200 from these, so it will be 10 plus 2 plus 18, so 200 times 18 plus 1800 times 2, 1600 plus 1200 times 4, 4800. That's going to give us 10,000 watt hour, but keep in mind that the question is asking us kilowatt hour, which means you have to divide this by 1000 kilowatt hour. That's the answer for the A part, and B part is pretty easy. We just have to find the average power per hour. We have a total of 24 hours in here, so the average power would be simply the 10K that we have, or 10,000 watt hour divided by 24 hour, and that's going to give us divided by 24, 416.7 or 67 watt. We don't have a specific unit for the B part, so that should be good for the B part of the question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.